Hello, my name is Eric Schoppen. I'm invited to the BGI Summit for my expertise. I have a background in cognitive and social neuroscience. I'm an educator. I work in education. I'm a lecturer at the University of Applied Science in the Netherlands. And I hope to bring my expertise and knowledge to this summit to bridge the gap between biological trust systems and artificial trust systems. If we talk about trust, that's a multidimensional construct. It consists of expanding layers, and every layer is increasing in complexity. So that's my definition. Now, this is a very abstract definition I can understand. So we have to start at the beginning, and it's of course how trust works in our brain. We have three biological forms of trust. We have cognitive trust, which is the reasonable, conscious side of trust. We have affective trust, that's more the emotional part, that's more intuitive. And we have cognitive behavioral trust. And this is actually the oldest form of trust that resides in the brain. And this is all about behavior, how we react to our environment. Well, these three components actually form the basis for our self-confidence. So this is the me part, so to speak, for trust. If you cooperate with other people, this is cooperative trust, because you have to work together, you create social relationships. I mean, we are socially wired. And in evolution, this created also that we created and cooperated in larger groups. So we formed teams, for example, for hunting, and now, of course, we have teams in organizations. This brings us to the next layer. This is organizational trust, that these teams or groups working together, organized in larger tribes or branded organizations. And this is actually in the here and now, so it's not in the old evolutionary part. And if you look at the future, now we're becoming more and more dependent on trust systems, and these are in the system trust layer. So look, there's a lot of going on at the moment in developments. So for example, the oldest form of trust systems, system trust, is our belief in money, in our banking system. And of course now we have the transition that we have to place our trust in artificial intelligence systems. So for example, if you use social media, if you use electronic banking, all these kind of things. And the last layer, that's the total layer, that's a socio-economic trust, and that is of course all the resources that we use in society where we're dependent on. So this is the society trust layer. Well, there's a difference between biological trust systems and artificial or digital trust systems. In our brain, our biological trust system is based on a neurochemical system. I mean, our nerve cells, they communicate with other nerve cells based on actual potentials, and in the synapses with neurochemicals. So there are different, we have around 50 to 100 different neurochemicals. So for example, dopamine, glutamate, all these kind of chemicals. And they give us also feeling. So that's the difference between computers. So if you process information in your brain, for example, when you're thinking of something or you have thoughts, it's also arousal, give you a feeling of arousal or joy or pain or sorrow, depends on the information that you process. So for example, when you read a WhatsApp message and you have a relationship, but I met someone else this night and I break up, then you don't only read that sentence, but of course you feel something as well. This is about the neurochemical stuff. So every thought that we have, every information that we process, it's going through the limbic system, gives us these feelings. Now, if you talk about artificial trust systems in computer systems, they are binary. So they're fully electrical. And they actually, even if you make AI systems self-reasoning, they don't understand these feelings. So you can maybe program or maybe self-programming to mimic these processes, but actually it's not what makes us human. The feeling that you have, for example, when you're walking outside and you experience the air and you're hearing the birds and you're enjoying yourself and you're floating away, that's very hard to mimic in computer systems. So that's the big difference. And it's not even a gap between those two systems, it's a void. It's so huge that I have doubts that we can overcome or close this void, bring it together, that HEI really understands our deeper emotions and deeper drives, which are totally irrational anyway. If we look from these trust systems that you just talked about, if you look at our brain, your brain is a connection machine, but it's also a prediction machine. That's the main function. It tries to predict the future to be adaptive to our environment. So when something is changing, or you can see or predict that it's going to change, then your brain actually prepares you for that change. And so it's very difficult for our brain, for example, to extrapolate decisions over a longer period of time. So this is why we react immediately when we have pain. But if you tell people when you're smoking you will die over 30 years, that makes no sense for our brain, because your brain is living in the here and now. This is how our brain is wired, especially in the older regions in our brain. Now, if you think about a sustainable future, we have to adapt these long-term visions for our brain in an encoded way that our brain understands. So you have to bring it in the here and now. So it's not about okay, we're polluting the world and over 30 years the temperature is very high. But it's more easy to say to people, well, at this moment you pay more for your gas price, or you pay more for your food, we have water shortage, all these kinds of things are more urgency. And if you talk about the influence and impact of AGI, which is not here yet, so it's very hard to predict that future, but my vision is that if we talk about sustainability, and saving our environment and creating a more social environment for our society and as humans, HAI can play an intermediary role because it can easily understand the complexity of all ecosystems in this planet. I once gave a TED talk and I made a difference between a voting system, which we do as humans. I mean, we have a democracy and you can choose your party, which you like. And I proposed a voicing system with HEI that can listen to all the complex ecosystems in the world. And you give the ecosystems on the nature in this planet also a voice. And they should be equal. So the human is not more important, which was always, we are the central species, right? And now, of course, this is changing, maybe by a complete new role with artificial intelligence, which are better, smarter, can make better predictions for us as humans. So that's the role of HEI for me. Yeah, well, if you look at the people-planet approach, for example, I think that's it's not a difficult model, but it's very easy to understand for a broad population. So the people approach is, of course, very clear. We have to change our behavior. It's a really strange time at the moment that we have wars. And when we are in war, we don't talk about sustainability anymore, which is, I think, it's still important. So therefore, you need also the planet approach. And as I said in my previous answer, they are equal. So the one is not more important than the other. And if you want to solve all these large problems at the moment, which are accumulating, we need smarter systems. Now these are AI systems, which can be very beneficial or easy, also in this moment. I mean, for me, it's very strange that the big tech companies using all this brain power, so to speak, which is energy consuming, water consuming, to create more movies, to more click behavior on social media apps. I think that's not the way to go. That's my personal opinion. Of course, everyone has the right to enjoy their addiction for 4 or 5 hours a day. That's fine with me. But that's not the way forward if we want to preserve this planet. So I think, therefore, we need AI maybe to control our addictions as well. Well, that's an interesting question. What can make AI hallucination? There are some definitions and some theories. But the analogy I want to make is that your brain is actually a dream machine. This is the analogy. So when you go to sleep, you process information, what you experience in your episodical memory from that day or the last week. Because it's consolidating these kind of memories to the long-term memory system. And when you dream, actually your brain is shut off from the outside world. I mean, you don't have contact with the outside world, right? You don't have new sensory information. So your brain is actually making up a world which is totally irrational. It's a hallucination, and we call this dreaming, right? And these dreams can be very, very realistic, but they can also be very strange at some points. Now, if we go back to the large language models like GTP or whatever, these are actually dream machines. They are filled with data, they process those data, and sometimes they are right, they give the right answers, and sometimes they are hallucinating in their own dream world. But for this system, it's completely correct, because there's no right and wrong. It cannot reflect on itself if the answer is right or wrong. So that's the analogy. Well, I mean, when I was studying also part of the computer science, it's garbage in, garbage out, right? So it depends on the data. If the data is biased, then you get biased results. So there are two ways you clean up data, which is hard because it's a lot of data processed. It's like Google says all the information in the world, right? So, but actually what you can do, you have to clean, but cleaning mean that you have to remove biased data, but it's impossible. What you do is you change the threshold. So if you say, okay, render 5 CEOs, you get 5 males, white males, right? So what you have to do is remove a lot of this data from the males so that the females and colored people are equal in balance. And this is a very hard process, and we don't have the tools at this moment to clean it up in this way. So this is the biggest challenge. If you want to have an unbiased systems, actually you have to start from scratch. You have to start all over again. Why is AI so controversial? Because it has impact on all the layers I discussed in my answer in the first question. So we have on a micro level, we have our neural networks. There are now processes going on like Neuralink that with invasive technology that can tweak around in your mental processes. It can have influence on your emotions. So that's on the micro level. On the meso level, this is how we have social relationships. Well, in the near future, everyone will use AI agents to represent you in the virtual world. right? So what will happen if you're in a relationship or you meet new people and everyone is represented with an AI agent or AGI agent, that doesn't matter, they will talk to each other because they are the representatives of you in this virtual world. Well, we have trust systems, the biological trust systems, but the AI agents, they have their own trust systems. So they are going to communicate and make decisions and make contracts, social contracts, that are not yours trust systems. These are not your decisions. And these will have high impact. So that's also an important one. And then they have the micro, meso, macro level, the macro level. And this is that it has impact on all the larger ecosystems. So we are dependent on the big tech companies, which will implement AGI. Governments will implement it. And that's not always beneficial. Because if, for example, when we implement an AGI system that should protect us and the planet, right? Then it can be the case that when people still do stupid things like war, pollution, whatever, then the AGI say, okay, I have to protect, and then the planet is more important than us as a species. So it will become repressive. It will not kill us. But for example, it will prevent flying. So what the AGI will do, it will hack all the computer systems that make flying possible. And then you're stuck. And that's not what no one wants. So we want to keep all our freedoms. We want to keep all our privileges in this world. We want the benefits of AGI. And we want to save the planet. Well, I ask you, is this possible or not? How do we keep AGI humane, right? Well, it depends on what you find humane. This is about ethics, trust ethics also, but also moral dilemmas. You know the classics with the self-driving car. Should it save the driver or kill the pedestrians, or save the pedestrians and kill the driver? Well, of course, all car manufacturers say, okay, it should save the driver. All insurance companies says, no, it should kill the driver, it's cheaper. So, right, and I think that's option C is for me much more interesting, is that it's like a kill switch. When the car is coming in a situation when an accident is inevitable, it gives the control back to the driver, because it goes back to the status quo. So when we make something better and we find out that something better is not working, we go back to the last phase. And the status quo is now that everyone is insured and is protected by legislation and by law, that you're responsible as a driver. So that's option C. So if we want to keep AGI humane, probably it will give back control to us as rational humans. And a lot of people find this a very crazy idea. But if you don't have control anymore, then the AGI system is not humane. It's a very philosophical answer. I think we have to learn, that's my personal message, we have to learn these AGI systems that the small things in life are the most important. That we have to learn this system. It's not only cognitive, that it can make calculations faster or predicting the future way much faster than we do. So, for example, your AI agent can predict your behavior much faster than you. So they mimic our neural networks. So, and they can predict what you're going to do next week, maybe over a year, maybe your whole life. Is that humane? So it should protect you from stupid things. That's the first thing. But it also should allow you to enjoy your own enjoyment, the small things like walking in nature, having fun with friends, and not interfere in these processes. I think that's the most important one. Well, that is a danger. If we give all our decisions to the AGI systems, well, we don't have free will anymore, but we're totally dependent also on the decisions that we don't like. And I see this, for example, when people are trying to find a new partner. They have a wish list that long, and well, AGI cannot solve these kind of problems. So what you get is a system that will match you with people or match you with systems that is beneficial for the AGI system, because it can control the whole population in a much better way. But is it beneficial for us? Where's the surprise in your life? Where's the pain and the friction which we need? I mean, this is our emotional package. We have an emotional spectrum, and it's not only joy and efficiency or making money and get wealthy or whatever, but it's also being surprised, maybe have an experience that you don't expect. Maybe you have to experience the being angry or being depressed or feeling sorrow for something. Because without sorrow, you can't have relief. And the relief is very important for the neurochemical system in your brain, because it's a healing system.